Alright, y'all, we are in day 2 of chapter 2. We are going to review what we talked about last time in practice with Z-scores, percentiles, and cumulative relative frequency distributions, which is just a fancy way to represent percentiles to give an estimate. Now, where we left off from last time is we were talking about Z-scores. Okay, and Z-scores was a way to relate unlike sets in a way that they had the same label every single time, and that same label was in terms of standard deviations. And a Z-score we talked about can be positive or negative, but that indicates whether our value that we were given was above or below the mean. So I'm going to have you add on to the side here. It's not just standard deviations, it's always going to be standard deviations above or below the mean. Next thing we're going to talk about is percentiles related to quartiles. Quartile 1, quartile 3, and then the median, which is actually quartile 2. Okay, so let's review just for a second on how to calculate quartiles. I made up a just basic set here. Remember, the median is the middle as long as you have ordered them. Okay, cross off on both sides, or I have 7 things here. Half of 7 is 3.5, so I'll have 3 on each side. So there's my median. Once I find the median, then I remove it to think about the quartiles. So quartile 1 is the median of the lower half, so that would be 2 for us. And quartile 3 is the median of the upper half, that would be this 18 here. And why we're reviewing this is because we want to talk about this in terms of percentiles or rankings in the system here. Okay, so if we think about percentile, I chose that all of these are different. Quartile 1 was the number 2, and it was at or below 2 out of the 7. Okay, so as a percentile, 2 over 7, that looks like about 29%. Okay. But when we're talking about quartiles in general, we're talking about splitting the set in half to find the median, and then splitting it in half again to find the first quartile, or taking our number 7 and quartering it, and getting that, we've got 1 3/4, and that gets you almost to the second term, which almost gets you to the right place in terms of location of where that would fall. And this is the idea or the estimate that we're going to talk about here. If we're given the raw data, y'all, we are going to calculate things by hand because it's the most accurate way to do this. Quartile 1, find it by doing the median and the median again. Okay, percentiles, if you have the set, come up with your ranking like we did with this 2 over 7. But if we don't have it, what we can do is an estimation, okay, and that's using the idea of quartering it. A quarter is 25%, or 0.25, and that is the 25th percentile. Okay. So when you don't have the set, an approximation for Q1 is 25th percentile. Same thing with median, that's the middle or the halfway point, which would translate to the 50th percentile. Okay, quartile 3 is a quarter of the way on this side, or 3/4, that's about 75%, so 75th percentile. Okay, so those can be used as good estimates if we're trying to find where those quartiles land. Okay, we're going to do some practice problem that ties everything we did last time together. Okay, so the first one says here, according to a 2019 article, the state of Pennsylvania was at the 82nd percentile for pre-K to 12th grade and was at the 0th percentile for higher education. And we want to just explain what these mean. Okay, we weren't given the individual scores, so we are not going to be able to find that. We're just going to use comparative language here to talk about what this means. Okay, remember the definition of percentile is at or below. So this 82nd percentile, would mean that Pennsylvania ranked higher than or equal to 82% of other states, because that's what we're comparing it to, in this category of pre-K to 12th grade education. Okay. And then we're going to change gears and talk about this 0%. Now I mentioned this a little bit last time, but we're going to chat about it again. A 0th percentile for me does not exist unless there's a very, very rare situation that's happening. Okay, here's how this would look. We talked about this last time, that the only way to talk about percentiles for me is a ranking system of some number over some number, where the top number is your order in the list, so you're ranking your spot, and the bottom number is the total number of items. So the lowest possible ranking where we could be is first in line, lowest to highest. The only way that 0 is going to pop up is if this bottom number is so big that the fraction would round to 0. Okay, so this is going to happen very rarely. But in context of this situation, since they're asking it must exist, again, the only way that this can happen is if that top number is 1, meaning that they ranked last. Okay, so translating using the same language, Pennsylvania ranked higher than nobody. Okay, but you could also state Pennsylvania was last in this particular category. So Pennsylvania, always going to include context here, ranked lowest compared to the other states. And this one was for higher education. So they were not doing a good job. Okay. Alright, now we're going to just practice when our set of data looks a little bit different. So we did practice with a dot plot, and now what we're going to do is practice finding percentiles in terms of a frequency table. So here it says a teacher gave a quiz that had a maximum of 20 points, and then its chart gives the score X, so this is 7 points, 9 points, 12 points, and somebody down here did get 20 out of 20. And then the frequency, meaning how many different students scored that point value. Okay, so just for example, this section right here would mean 3 students had a score of 14 out of 20. Alright, so what we're going to do first is figure out how many students took the quiz, and that means adding up all these values here. Okay, so totaling it up here, you can toss as much as you want in your calculator. We've got 50 students. Okay, go ahead and put that over here, which means when we do our rankings, now all of these are going to be out of 50 students, and it says how many students have scores less than or equal to the score at the 92nd percentile, and then what score is that? So we assume that the 92nd percentile is pretty high. It could be this last group, or it could be one of these groups below here. So what we're going to do is just calculate a few of them so we can see where this 92nd percentile falls, and then I'll show you another way we can do this as well. So first of all, this last group is going to be your, because all of them are below, this is going to be your 50 out of 50, which is your 100th percentile. And that sometimes we talked about is represented as 99th as well. Okay, I'm fine with just doing the math and using that 100%. Okay, and then we're going to go on to the next one here. I've taken 1 away, so now I am at 49 out of 50. Okay, but you can always count them this direction as well. And that would be 98. So I'm going to put that down here because I ran out of room. Okay, just taking, I know that 50 times 2 gets me to 100, so 49 times 2 is my 98. And then we're going on to the next one. Now I can take 4 out. Okay, if I take these 4 away, that would mean I have 46 out of 50. And that's where my 92 is showing up. Okay, again, 46 times 2. So here it says how many students score less than or equal to that score. And so that top number would be 46 students. And then it says what is the score? That would be the score is 18. And it was talking about points, so we'll say 18 points. All right. But I told you I wanted to show you another way that we can do this as well. And that's thinking about, remember, this is 92nd percentile, means 92nd or 92% of the total students, which was 50. And we could do that as 0.92 times 50. And that says the 46th person in line. Okay, and that's what we did. 1, 2, 3, 4, 5, 6, 7, 8, all the way up until we get to 46. Find the group you're in, and that's it. Okay, then it says what score represents the 34th percentile. Okay, so for this one, I would assume it's going to be on this lower end when I'm calculating. There's no reason to list all of them if you don't have to. Okay, so 34th percentile, we're going to go the other direction. There's only 1 student in this group. Okay, so that's a 1 out of 50. And that's going to be the 2nd percentile. Okay, then here, 1, 2 people are lower, 2 out of 50, which is the 4th percentile. And then here we've got 2, 3, 4 out of 50. That's the 8th percentile. And then we've got 5 out of 50. 10th percentile, and I may end up having to calculate quite a few anyway, it looks like. And then 8 out of 50, 16th. We're adding on 9 more, so that's 17 out of 50, and there we finally get to the 34th percentile. Okay, so for this one, what score goes with that? That was our 15 points. Now this next one, it says, is there a score that represents the 64th percentile? Okay, so one option is to continue this to find the missing ones. Okay, we only have 2 left, so we'll go ahead and look at what that would do for us. Okay, so when we add on our 16 here, we are at 33, and then that looks like 66th percentile. And then here it was asking about the 64th percentile, so that tells us no, there wasn't, because it went ahead and skipped all the way from 34 to 66, so we are missing that little chunk in between, so you're just going to say no, there wasn't. But another way that we can do this, I just want to talk about different methods here, is going backwards. So here's how this looks if we go backwards, kind of like what we did here. So we are taking 64% of 50. And it's not as obvious as necessarily for all sets, just making sure it's a whole number. Because a whole number comes out here, it's more about how these groups are calculated. So this says the 32nd person would represent the 64th percentile if it exists. Here's how we know if that actually works for us. If we go through here, and you can look at the top numbers here because we already did that work here, but what you would be doing is counting to find where the 34 person falls in line, And so that would be right over here in this group. But remember, when we're thinking about this like a dot plot, we've got 9 total dots here at this score of 17. And as soon as I go from this 33 group to the 34, I would have to count all of these values going that direction to calculate my percentile. So if that person you come up with, which was 32, is not the last person in their group, so I guess I was in this one, not this one, was not the last person in their group, then it's not going to be a percentile. Okay? It may be best, if you have a table like this and you're answering lots of questions, to just go ahead and take the extra time to calculate them all, and you'll visually see which ones exist and don't exist. Okay, so this one, it says what score represents the 8th percentile, so it does exist. Going back to our table, that's one that we have, so the score itself was 12 points. Last one here, it says how many students scored at or below the 80th percentile. Okay, first would be understanding, do we have an 80th percentile? Okay, at or below doesn't necessarily mean there is one. Okay, so our very last group here, we would have 42 over 50, and that would translate to the 84th percentile. There wasn't one. So we need to find at or below where 80 would be. Okay, so 80 for us would be right in here somewhere. So these ones don't count because they were higher. We just want to go that direction from them. And from our work before, that was 33 students. Okay. This is the only way you can calculate something like this, because if you use the 80% times the total, it will not give you that 33 students that you actually need to show up because there was such a gap, such a big gap that was popping up in our table. Okay. All right, what I want you to do is pause the video and try the true and false for number 3 based on what we talked about. Okay, so here it says all data points less than or equal to the median correspond to the 50th percentile. Okay, that one is false. Okay, 1, the median itself does not have to be the 50th percentile. But if it is, it will be at the 50th percentile, not all of the points and the median being the 50th percentile. Okay, that's going to be a rare case where that would ever happen. Okay. Next one, all data points in the IQR correspond to the 50th percentile. That is also false. Okay. Now, on this next one, if there are 12 different ordered numbers, the third lowest corresponds to the 25th percentile. Okay, so for this one, we have a number in our set, 25th percentile, 0.25, and we take it times 12. A quarter of 12 is 3. So the third lowest would correspond to the 25th percentile. This one's true. Okay. All right, this next section is talking about Z-scores. So we're going to review what that looks like. So a student had a Z-score of 2.2 on a history test, on which he received an 85%. So we're told two things here. The Z-score is 2.2. And that's positive, so that tells us standard deviations above the mean. Okay. Then the next thing we're told is the score itself, okay, we call that the raw score, okay, but you can just say value if you want, was 85%. And the teacher said that the class had a standard deviation of 3.1. And because we're talking about a score on a test, the standard deviation would also be indicating percent values. And it says, what was the class average to the nearest tenth? So we're trying to find the mean. And we can do so because we have all of these pieces, and we know the formula for Z-score is the value minus the mean over the standard deviation. So let's just fill stuff in. Z-score was 2.2, positive. Okay, the raw score we were told was 85. The mean we don't know, that's what we're solving for, and standard deviation was 3.1. Okay, so from here we're just going to multiply that denominator over. We've got 6.82. And then this one is 85 minus the mean. Okay, here we've got to do a little bit of work because this is a negative. So I'm going to subtract this over. But we still have to get rid of the negative as well. So I have this in my calculator, minus 85. There's that. And then divide by the -1. And our score was 78.18. It says, what was it to the nearest tenth? The reason they're asking you to round to the tenth, even though this came out to 2 decimal places, is remember, standard deviation is an irrational number, so they likely rounded that anyway. So that's why we're hacking it off a little bit early here. So we're going to say that's about 78.2%. So the average was approximately 78.2%. Okay. Next one, ask a bunch of questions related to this table because we did a practice together and Z-Scores was the last thing we talked about. I'm going to ask you to pause the video and see if you can try these ones on your own. Okay, we're going to talk about these real quick. The first one was asking for the Z-score. Make sure when you write your answer you're doing 2 things. Following the instructions, it said to the nearest tenth, so tell me approximately 1.2. And then you are including the language above the mean when you're giving your answer. On part B it says, which test did Leonard do better compared to others? If you look at these scores, Leonard was below the mean on chemistry, but he was above the mean on government, which means this is going to translate to a positive Z-score. This one's negative. It's automatically better without the work. Okay, you can't jump to that conclusion when you have one positive and the other one also positive. You got to actually do the math here. Okay, but we're going to talk about these ones together because they were a little bit strange. Said Howard scored an 82 on the chemistry test and he was equally well in terms of Z-scores on the government. This says that the Z-score on the chem is the same thing as the Z-score on the government test. And that's how we're going to set up an equation here. So for chemistry, we're looking at 82 and the mean. So 82 minus 78 over that 8.6. And then on the other side, we're doing the government test, which they didn't tell us what he did. So that's the X. And then we're taking the mean for it, 80 over 10.4. Okay, and from here, we can simplify in a couple different ways. I'm always going to recommend that you do some subtraction if there is any to happen, but then also we can cross-multiply at that point if we want to. So for here, I'm going to start simplifying here. This is 4, and then I'll go ahead and cross-multiply from there. So on the first side, we've got 4 times 10.4, and that gives us 41.6. Not the only way to do it, but the way I'm going to do it. And then we're cross-multiplying on the other side, realizing that this 8.6 has to go to both terms. So 8.6x, and then we're going to take our 80 times 8.6 to get 688. So minus 688. Then I can add that 688 over. So I'm just going to add that to 41.6. And our final step, we've got 729.6 equals 8.6x, and we can divide that over. Giving us a score on the government test of about 84.8. So this one is going to be a little similar. It says Raj had the same score on each test, but they didn't tell us it, so that has to be our X. But he also had the same Z-score. So same process as the last one. We've got some Z-score equal to another Z-score, but we're also going to have an X on both sides because they did not tell us anything about Raj's score. Okay, so we can still steal from the chemistry side the mean of 78 and the standard deviation of 8.6. Then on the other side, we don't know this part, so it's X minus 80 over that 10.4. Okay, so here we're going to distribute through. And this first part is going to look the same as up here. Okay, so this side of it is 8.6x minus 688. But the other side, we've got to take this 10.4 times here, and we're remembering to distribute it through. So 10.4x, and then I need to take that 78 times 10.4, and that's 811.2. And then we can do some math here. Okay, so I'm going to add that 811.2 over to my negative 688. So that's minus 688. And that gives me 123.2. And then on the other side, I'm going to subtract that 8.6 over. So that is 1.8. And then I can divide it to finish up here. And we've got a final answer of 68.4 repeating, but remember we are going to make sure we round because the instructions tell us to. So it's about 68.4. So Raj got a 68.4% on both tests. Last problem here is related to a graph. This is just a quick estimation. Remember, if we do not have the raw data, we cannot find these exact values. We're just estimating using the X and the Y axis. So it says about what percent of states have in-state public college tuition less than or equal to 80%. This is a cumulative relative frequency, which means the less than or equal is already built in. We just have to find this 8,000 on our x-axis. So here it is. Find where it corresponds on the y-axis and report that value. So it's about 60%. Okay, this last one asks us for a few things. Estimate Q1, Q3, and IQR based on what this would be. And remember, this is going to be approximately, when we're just rough estimating, 25%. So this time, we're starting over here. Here's where 30 would be. So 25 would be about here. Nice on that dot for us, and we're coming down. So Q1 is approximately, in dollars, 6,000. Okay, Q3, we're doing the same thing with 75%. So here's where 70 would be, 75 would be here. Gave us a nice dot again. And that's 10,000 looks like. And then the IQR, because IQR is Q3 minus Q1, just has us subtract these two things. So our IQR would be about 4,000 based on our estimations from the previous part. Okay, so that's everything you should need to know about percentiles, Z-scores, and cumulative distributions for your homework. Okay, you can work on your homework the rest of the hour, and then if you have questions, be sure to check your answers, or you can send me an email with whatever you have.